Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi everyone, welcome back to day 23 of 100 days to CAT Quant series. Today we'll be discussing 5 questions from geometry. So whenever you come across a question on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. Now in case if you want to solve this as a test, you can log on to www.thegurukul.org.in. We'll be providing the link in the description. You can sign up. There you'll come across a course 100 days to CAT in which there will be 100 tests of quant, LRDI and VRC. Right. So you can start attempting them for free. Right. Now without any further delay, let's get started with the first question. Now in the figure below, AB is equal to BC is equal to CD is equal to DE is equal to EF is equal to FG is equal to GA, then angle DAE is approximately. So in this triangle, we are asked to find the approximate value of this triangle. So this angle, let me consider that as theta. Now let's try using one by one. And to answer this question, all you need to know is in a triangle, the angles opposite to equal sides are equal. Sum of all the three angles in a triangle is 180 degrees and straight angle is 180 degrees. Now, let us first use AB is equal to BC. So, AB is equal to BC. So, the angles opposite to these two sides should be equal. So, if this is theta, the angle opposite to this side should also be theta. Right. Now, in a triangle, right, the exterior angle at a vertex is nothing but sum of opposite interior angles. Now, the exterior angle at vertex B, now this should be sum of these two angles, 2 theta. Now, we have theta, we have 2 theta, we have theta here. Now, let's see if we can use any of the given equations or any of the given sides, right, where we can use theta or 2 theta or theta. Now, this is also opposite to BC and also GF in triangle AGF, right, and it is also given that AG this side is equal to FG this side. So in triangle GAF, right, the sides opposite to this angle and this angle are equal. So this should also be equal to theta. Now in the triangle AGF, this is nothing but the external angle of the triangle at vertex G, which should be equal to sum of interior opposite angles. So sum of these two. Now this should be equal to 2 theta. Right. Now we have this angle, right? Now what is the side opposite to this angle? This one, right? So if GF, is it given that GF is equal to EF, right? So EF is equal to FG. So if this is 2 theta, right, this angle opposite to this side, the angle opposite to this side, this should also be 2 theta, right? Now do we have any other thing that can be used? Now BC is equal to CD. Now we have CD side opposite to this angle. Now BC is nothing but side opposite to this angle. So this should also be equal to 2 theta. Right. Now in this triangle GFE, we have two angles. Right. So we know that the sum of all the three angles in a triangle is 180 degrees. So 2 theta plus 2 theta plus angle GFE should be equal to 180 degrees. So the measure of this angle should be 180 minus sum of these two, 4 theta. Done. Now similarly, if you consider a triangle BCD, this is 2 theta, this is 2 theta. So the measure of angle BCD should be again 180 minus sum of these two, 2 theta plus 2 theta, 4 theta. Done. Now, all these three should add up to a straight angle 180 degrees. Theta plus 180 minus 4 theta. 180 minus 3 theta plus this angle should be equal to 180. So that means the measure of this angle is 3 theta. Right. And similarly, theta plus 180 minus 4 theta. 180 minus 3 theta. Right. Now, the sum of all these three angles should be 180 degrees. So, the measure of this angle should also be 3 theta. And it is also mentioned that FE is equal to DE. So, these two are equal. So, if this is 3 theta, the angle opposite to this side should also be equal to 3 theta, right? So this should be equal to 3 theta. That means this measure of this part should be equal to theta. Now similarly, if this is 3 theta, given that BC is equal to DE, and this complete angle should be equal to 3 theta, or the measure of this part should be theta. Now let us consider the larger triangle ADE. In the triangle ADE, the sum of all the angles should add up to 180 degrees. Theta plus 3 theta, 4 theta plus 3 theta. 7 theta should be equal to 180 degrees, or theta is equal to 180 by 7, which is approximately 25 degrees. Hence option D should be the answer. Now coming to the second question. In triangle DEF, as shown below, points A, B and C are taken on DE, DF and EF respectively, such that EC is equal to AC. So these two sides are of equal length, and CF is equal to BC. Now these two are of equal lengths, right? EC is equal to EC is equal to AC. So these two are of equal lengths, and these two are of equal lengths. Now if angle D is 40 degrees, now if this is 40 degrees, what was asked? We are asked to find angle ACD. We are asked to find the measure of this angle, right? Now let's apply the same property. If I consider this to be angle X, this should also be angle X, right? And if I consider this as angle Y, this should also be angle Y. Now in the larger triangle DEF, we know that the sum of three angles should be 180 degrees. So X plus Y plus 40 should be equal to 180 degrees. This implies sum of the angles X and Y should be 140 degrees. Now we have the value of X plus Y, using which, okay, we should be able to determine the measure of this angle. Now if this is X, this is X, the measure of this angle should be 180 minus sum of the other two angles, 2x. Now similarly, this should be 180 minus 2y, and the sum of all these three angles should be 180 degrees. So what do we have? 180 minus 2x plus, let me call this as theta, theta plus 180 minus 2y is equal to, this should be equal to 180 degrees. So I can cancel these two on both sides, or theta is equal to 2 into x plus y minus 180 degrees. So we have the value of x plus y, 142 into 140, 280, 280 minus 180. So the answer for this question should be 100 degrees, hence option C. Now coming to the third question. The length of the common chord of two circles of radius 15 centimeters and 20 centimeters, whose centers are 25 centimeters apart is, right? Now we are given with the distance between the centers of these two circles, that being 25 centimeters, right? The radius of the smaller circle is 15 and this is 20. Now we are asked to find the length of the common chord. Now if there is a common chord between two circles, then there is a property. The line joining the centers of the both circles will bisect the chord and also will be perpendicular to the chord, right? Now the easiest way to solve this question is if you get to identify that this is a right angle triangle. Now how do we get to identify that this is a right angle triangle? Ratio of sides. Now what is 15 is to 20 is to 25? 3 is to 4 is to 5. Pythagoras triplet. So if the sides of a triangle are in the ratio 3 is to 4 is to 5, right? So that's the right angle triangle, right? So that can be of form 3x, 4x, 5x. For example, 6, 8, 10, right? They form a right angle triangle. 12, 16, 20, right angle triangle. So here we have 15, 20 and 25, right? So if I consider this to be theta, let this be alpha, and this should be the right angle, right? Now in this smaller triangle, with hypotenuse being 15, right? Now this will be alpha. We can apply the rule of similarity here. Now, when the hypotenuse is 25, the side opposite to angle theta is 20. Now, when the hypotenuse is 15, the side opposite to angle theta would be, if this is 5 parts, this is 4 parts. So, if 5 parts is 15, 4 parts would be 12. Now, if this is 12, this will also be 12. So, the answer for this question should be 24 centimeters. Now, the key to solving this question in the least possible time is identifying that this is a right angle triangle. Now coming to the fourth question. In the figure, ACB is a right angle triangle, right angle at C, CD is the perpendicular. Circles are inscribed within the triangles ACD, and it's not BAD, it should be BCD. Right. Now P and Q are the centers of the circles. Okay, if P and Q are the centers of the circles, we are asked to find the distance PQ. Right. So these are incircles within the right angle triangles. So what is the formula to calculate in radius of a right angle triangle? It is R is equal to semi perimeter minus hypotenuse. Right. Now if you observe, this is a right angle triangle. So if the sides are in the ratio 3:4, the hypotenuse should be of 5 parts. So the length of AC is 25. Right. Now in the larger right angle triangle ACB, if the side opposite to angle A is 20 when the hypotenuse is 25, that means when this is 5 parts, the side opposite to this is 4 parts. Now if the length of AC hypotenuse is 50 units, the length of CD should be 12 units, or you can as well find the length of CD by applying area of right angle triangle. Now area of right angle triangle is nothing but half into product of perpendicular sides, 15 into 20, or which is same as half into base into height, where base is the hypotenuse. Right, I can cancel these two, 5s, 3s, 4s, or the altitude is of 12 units. So the length of CD is equal to 12. Right. Now instead you can simply use the property of similarity of triangles, and you can get the length of CD to be 12. Right. Now coming to this right angle triangle CAD, if the length of the hypotenuse is 15 and if the length of one of the perpendicular sides is 12, the other side should be of 9 units, so that the ratio would be 3:4:5. Similarly, 3 parts, 5 parts, this should be 4 parts, which is 16. Now what is the semi perimeter of this triangle? 9 plus 15, 24, 24 plus 12, 36. So 36 by 2. Semi perimeter is 18 minus hypotenuse is 15. So 18 minus 15, 3. So the radius of this in circle, the in radius of the smaller circle is 3 units. Now what is the semi perimeter of the triangle CDB? 12 plus 16, 28, 28 plus 20, 48. 48 by 2, 24. So 24 minus hypotenuse 20. Now this is equal to 4 units. So this part is 3 units, this part is 4 units. Now let me drop a perpendicular from P to the other radius. Now we know that this length is 3 plus 4, 7. Now this is 4 units, this is 3 units. So this should be 1 unit. Now what was asked? We are asked to find the length of PQ, which is nothing but hypotenuse in this right angle triangle. So 7 plus 1. So under root 7 square, 49 plus 1, 50. Root 50 should be the answer to this question. Now coming to the last question. Instead of walking along two adjacent sides of a rectangular field, a boy took a shortcut along the diagonal and saved a distance equal to half the longer side. Then the ratio of the shorter side to the longer side is. So let me consider a rectangle with the length of the shorter side being D and longer side being L. Right. So instead of walking like this, he walked along the diagonal. Now this is a right angle triangle, and the length of the diagonal would be L square plus B square. Right. Now because of which boy took a shortcut along the diagonal and saved a distance equal to half the longer side. So this distance under root L square plus B square should be equal to the distance taken D plus L minus L by 2 because this is longer than this distance by half of the longer length, right? So under root L square plus B square is equal to B plus L by 2, right? We are asked to find the ratio of shorter side to the longer side, so B by L. Now let's square on both sides. If I square on both sides, what do we get? L square plus B square is equal to B square plus L square by 4 plus LB. I can cancel B square on both sides. Now sending L square to the left hand side, we'll be having L square minus L square by 4, which will be 3L square by 4 is equal to L into B. Assuming that length is not equal to 0, I can cancel 1L on both sides, right? So 3L by 4 is equal to B, or this implies B by L, shorter side by longer side, is 3 by 4. So the answer for this question should be option D.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.